here on the screen. It's the back half of chapter 5, and it deals with inequalities. And you can figure out the meaning of inequality if you think of the word equality. So equality means that they carry the same value, they're equal in measure. Inequality means that they're not. So other situations besides equal would be if it were less than or greater than, or maybe not at all. You can see that there's a couple different symbols we're going to be exploring together this chapter. So 5.5 deals with just getting comfortable with the particular symbols. And I know you've seen them before. And maybe in 4th grade, 5th grade, you learned about Mr. Alligator. Who remembers about Mr. Alligator likes to eat the value that is greater? Remember that song? The hungry alligator eats the value that is greater. Not going to make me sing the whole song. Do you remember that idea? But anyhow, who has seen these symbols before? Less than, greater than, maybe not the graphing part, but have you seen the symbols where that symbol is pointing towards the smaller value and then the larger values on the open side? Have you seen these symbols before? Yes, Adriana's giving me feedback. Good. I need feedback in order to be a good teacher for you guys. So either type in the chat box or shake your head yes, or give me a thumbs up on the screen. But I really need your input to make this a good lesson, right? So if we read this paragraph up at the top, and you will see it's also on your chart that I would like you to glue in your notebook here. It says, you can use an inequality to show that two mathematical expressions are not equal. The table shows various symbols you can use to write an inequality statement and how to graph them on a number line. So today we're gonna, hi, I'm Zooming with kids right now, Jake. Hi, how are you? Your mask is on backwards, Bubby. That's one of my kids coming to fill up his water bottle. You have to give Mom a hug. It's almost his birthday. How many days to your birthday, Jake? 4 days till the big 8. Anyhow, this chart will not only show you the meaning of the symbol, but how to graph it on a number line, and we're going to practice that more this week, okay? So to get a little comfortable with inequalities, I thought I would play this little identification game called Inequalities Bingo. And you are welcome to just open up this page from Google Classroom and you can annotate on it. Or if you have it printed in front of you, just highlight the spaces that I'm going to say to you out loud. I have a calling card on the next slide here. And so I'm just going to recite the expressions out loud, and then you're going to go and find them. Now you might notice that some things are similar between two of the sections, but there's maybe one difference. Like for this one particularly, there's an X being represented as the variable instead of an N. And for these two, they look almost the same, except this one is showing a number is less than 12.5, and this one's showing when a number is greater than 12.5. So we're just going to get comfortable using those inequality symbols, okay? So you're just like when you are reading from left to right, you're looking at the symbol first on the left side of it, and then scanning across to the right side of it to determine if it's a less than symbol or greater than symbol. So if you come to this point where the tiny side, the pointed side is first, then that's showing less than. But if you see the part that has the open angle, then that's greater than, all right? So just from experience now, if this is greater than, what's this one called? When there's the greater than symbol, but then there's a little line also on the bottom. What is that referred to as? Anyone know? Paige, go ahead.
Means is less than or equal to.
So this one is greater than or equal to because the symbol first is wide on the left and it gets smaller to the right. So we say, what do we see first? We see the greater than side. So we say greater than or equal to. But yes, when there's the little line underneath, that means it's additionally could be equal to that value. Good job. So I'm looking at this symbol over here. Do you see the not equal at all?
Yeah.
So not equal means that it's just not that value. So we'll look at a couple today. All right, I'm going to start with the calling card. And I'm just going to read through some of these. And we're going to go highlight them on the screen, all right? So the first one says, the sum of 23 and 14 is greater than 36. The sum of 23 and 14 is greater than 36. So Paige told us about this one, is greater than or equal to, and that's not the one. Does anyone see another space that represents what I'm saying a little bit better? The sum of 23 and 14 is greater than 57. 36, sorry. 36. Anyone see it? I see it right over here. So I'm just going to highlight this space right here. This is the one that matches that phrase that I just said. All right, let's move on. The next one is the difference between, so you're looking for those key math terms, the difference, that's subtraction, the difference between 72 and 25 is less than 57. Anyone see it? Yep, right here on the top row. The less than symbol is tiny on the left and it gets bigger as you go to the right. So just like I'm reading from left to right, it's getting smaller to bigger. So we call this less than. The stuff on the left is less than the stuff on the right. The next phrase goes, 4 times 5 is less than 24. And so you're identifying that math word, times, and know it's a multiplication scenario. You're looking for something that takes that shape. So I see 4 times 5 over here. I see 4 times 5 over here. Which one fits the description best? 4 times 5 is less than 24. It's got to be this one, right? Because that less than symbol is shown between those two expressions. So far, so good? Yeah? All right, let's keep going. 5 times 8 is greater than 12 and 3/10. 5 times 8 is greater than 12 and 3/10. So I see a couple of instances where I see 12 and 3/10. I see 12 and 3/10 here. Make sure that we're picking the correct symbol that goes between those expressions. Greater than, okay? So the greater than side has to be shown first on the left. There we go. That's going to be the one. 71 times 2 is equal to 142. Okay, equal. That's a pretty easy symbol to identify. There it is. 71 times 2 equal to 142. We got it. We never colored our free space. Hope you colored yours. 26. 3 more than a number is greater than or equal to 20. 3 more than a number is greater than or equal to 20. So when I say more than, you're thinking about addition, right? So this one looks close because it has that greater than or equal to feature, but I know more than alludes to addition and not subtraction. So we're going to need to color in this guy over here. Greater than or equal to 20. All right, a couple more here. A number x is less than 2/3. A number x is less than 2/3. Anyone see it? Where's it at? Top corner there. Yeah, less than 2/3. The difference between 5 and a number is greater than 1. The difference between 5 and a number is greater than 1. Difference. Okay, that's a subtraction word. Oh, there we go. Difference, it's in the greater, it's pointing towards the greater side, is greater than 1. 6 is not equal to a number. Let X represent the number. 6 is not equal to a number. Let X represent that number. So between these two, I can see it's showing 6 is not equal to a variable, but I was told to use X as the variable. So I'm going to color that one. A number is greater than 12 and 5/10. A number, a variable, is greater than 12 and 5/10. Where are we at with that one? Oh, right up at the top. Greater than. A number is greater. Well, before I move on, could you give me a value that makes that equation or that inequality true? Could you give me a value for y? What are some values I could input into the expression to make this statement true? What value could y be? Come on, guys, unmute.
13.5.
Yeah, 13.5. Any others? There's infinite possibilities, right? Penelope said 13. How about 102? How about 3,104, right? Lots of things are greater than 12.5. So I have infinite possibilities for this particular variable. A couple more here. 28 is less than or equal to a number. 28 is less than or equal to a number. Anyone see that one? 28 is less than or equal to a number. Right over here. Now, tell me, oh, going back, wrong side. Tell me some values that would make that statement true. 28 is less than or equal to m. What are some values that would make this true? Would 4 make this true?
Yes.
28 is less than or equal to 4. Is that true?
Yes.
28 is greater than 4 though. So 28 cannot be less than. It's actually greater than, right? Isn't 28 greater than 4? So we have to pick a value that would make it true. It has to be less than or equal to. So what are some values that I can compare to 28 that would make this true?
30.
Yeah, 30, sure. Because 28 is less than 30, right? And now this equation or inequality is true. So I'm going to have to pick something greater than 28. I could pick 28 because that would be 28 is less than or equal to 28, but 29 would work, 30 would work, 31 would work, 32, and so on, right? Infinite possibilities. Good. Couple more here. Actually, last one. A number is less than 91 and 23 hundredths. A number is less than 23 hundredths. Where are we at there? A number, so I'm looking for a variable, is less than 91 and 23 hundredths. So could be this one. I see the numbers are correct, but the position, that inequality symbol's not. Here we are, less than. So what value could I use to make this equation, this inequality true? What value could I place in this spot to make it true? Got a couple people typing in some suggestions in the chat room. Penelope suggesting 1. Adriana said 40. Yeah. Ryan said 72. All of those would work. Why? Because they're all less than 91 and 23 hundredths. Good job, Daphne. So this activity, although we didn't get a bingo somehow, we could get a bingo if we could announce what this one is called, right? And I'll just let us color it. We could say a number is less than 12 and 5/10. So we have permission to color it now. Now we have a bingo, yippee! So there's our bingo for the day. But our skill today is about recognizing language that matches, yes, Penelope, bingo, matching language to equations. So we're going to continue studying this topic as the days go, and we're going to be learning how to then take it one step further and begin to graph it on a number line and represent our solution not only in number form, but in a model form on a graph, okay? So these are things that we're going to be learning about for the rest of the week. Your homework for today is with page 82 in your workbook, and it's related to some of these same things that we just practiced. You're going to need your inequalities chart to help you identify and translate between word form and expression form. You might also want your math notebook open to that page where it says words and math, because it has words like difference and sum and product, if those are a little tricky for you, okay? I'm gonna hang around here for a few minutes, but besides that skill, I will not be Zooming again with you until later in the week. The in-class people do not have math today, so I thought I would get a little ahead with you so that we could do this just alone and answer any questions that you still had about it while it's just us. I know it's hard to do when there's people in front of me and in front of you. It's kind of wild. So I'm going to pause the recording now, but I'm not going to pause the Zoom.